It's time to introduce arrays, stacks, queues, and linked list. Arrays are sequential structures, which are a type of data structure that can hold elements like a set. Up until this point, we have been sorting numbers in an array. These arrays must store only one type of variable. As long as you know the index of what you're looking for, you can go right to it in constant time or order 1. Anytime you are adding new elements to an array, you may have to allocate more space. If you insert into the front, you have to scoot everything down. This has an order in runtime. Deletion is also costly. If you delete from the middle or front of the array, you have to shift everything back over so they line up. This is because arrays must have one contiguous chunk of memory. This can also be order in. Because these actions can be quite costly, we sometimes trade flexibility for runtime complexity. To do this, we control the way in which you add or delete elements. We sometimes use other data structures. So even though arrays are the coolest data structure, if you don't know the amount of data you have or will constantly be inserting and deleting, you may want to use something different. Stacks are a type of structure called a LIFO, last in, first out, where you can really only do anything with the top element of the stack. Adding an element on top is called push, and taking off the top element is called pop. Now imagine that you are in hell, and by that, I mean standing in a long line. This queue is a FIFO, first in, first out data structure. Unfortunately for these guys, the only way out is going all the way through. The main operations are enqueue, adding to the end of the queue, and dequeue, removing from the front of the queue. In this structure, we have one pointer that points to the head or beginning of the queue, and a pointer that points to the tail or end of the queue. This all happens in constant time. These linked lists don't have many of the same benefits and properties of arrays, but will allow you to store elements of differing types and not have to worry about resizing. These treat every element as its own object. Each element has a pointer to the next element, or the previous, or both, as opposed to having consecutive blocks of memory allocated. Each link generally has 3 pieces of information. There is a key, a pointer to the next node, and pointer to the previous node. Additionally, there is usually a pointer to the head and the tail. Unfortunately, you must loop through the list if you want to find an element. This is one of the biggest downfalls since it had order in runtime. If you wanted to add an item to the list, you make another element of any type and move the head pointer and add in pointers connecting it to the rest of the list. If you wanted to delete an item from the middle of the list, you simply reassign the pointers around it. If you want to take one off the end, you reassign the pointers to null, and if needed, move the head or tail pointer. Luckily, inserting and deleting can happen in constant time.